We're on question 4 from this is our 4th video on our food response practice. This is our last video. So we've got question 4. The graph of F above consists of 3 line segments, which is just telling you that they're straight. No reason to wonder about curving. G is the function defined by G of X equals the integral from -4 to X. For each of these, find the value or state that it does not exist. Okay. So question 4, we've got G of X equals the integral from -4 to X of F of t dt. Okay, I'll put that there. And we'll put this down here. Part A asks for G of 1. -1? Yeah. So that's the integral from -4 to 1 of F of t dt. And so we've got those two are going to cancel each other out. So just this area, which will be -6 plus 1.5. So 7.5. -7.5. It's under the curve. Okay. And on stuff like this, if you don't show your calculations for how you found that, that's cool, because that's not calculus. The calculus is knowing, oh, I'm going to find the area under the curve. So again, these two cancel each other out. They're clearly equal. One is above the x-axis, one is below the x-axis, so they're going to cancel each other out. And then we have that. So clearly equal, all straightforward, everything else there. So G prime at, excuse me, -1. -1. Look, it didn't matter, but so these cancel each other out and nothing to do with it. Sorry, but either way, that's good. I don't have to do it twice. G prime of -1 will be equal to the derivative. G prime of x is equal to f of x. That means G prime is equal to f of -1. And f of -1 is -2. G double prime of -1 will equal the second derivative. And so we're looking for f prime of -1, and that means the slope at -1. Now the slope at -1 is undefined because it's 2. The slope on this side of it is 2, and the slope over here is 1/3, and so the slope is undefined. It said, or state that it does not exist. I'm going to give a reason. So it does not exist because f prime of -1 is at the cusp. It's a sharp turning point. The derivative is the limits don't agree. We can get into it a little bit more. All right. Part B. For the function defined in part A, find the x-coordinate of each point of inflection. So I want the points of inflection for part B. So looking for points of inflection. Points of inflection occur when the second derivative is equal to 0, which will happen when the or undefined. So undefined at x equals -1 we just found, equal to 0. Slope is 0. No, slope is 0. Slope is never 0. Okay, also undefined at 1. So those are the possible points of inflection. The sign of, so at x equals -1, there's no point of inflection. Because G g double prime of x does not change at x equals 1, there is a point of inflection because g prime of x is positive. See how it's positive and still positive? That's why I didn't change before. G prime of x is positive from on the interval from -4 to 1. I'm just going to go -1 to -1. And g prime of x is negative from 1 to 3. Okay, that's that. Part B. Part C says, let h be equal to this. Integral from -1 to x of f of the absolute value of f of t dt. Find all values where it has a relative max. Justify your answer. So this is a little bit funky. We haven't dealt with the absolute value, but not that big of a deal. Relative max means that we're looking for h prime of x to equal 0 and change signs. From positive to negative. Okay. So I'm going to just draw the absolute value here. And just on the interval from -1 to 3, which is all I care about, is this interval. So I'm just going to pay attention to that W I just drew. All right. So it's going to be a max. If we look at the graph, this is f, absolute value of f of t. Sorry. Okay. And so the derivative has the absolute value in it. Okay. I think. Okay. So from positive to negative. So positive. So this is negative. So this one's a min from negative to positive. This one's a max because it goes from positive to negative. Looking at the slope. All right. Let J of x equals the interval from 0 to x of f of t plus 2 dt. And again, there's some pretty simple tricks we can use. I'm going to start with one right here. And this is in our lesson we'll discuss on Monday, but it's kind of obvious. Okay. Break it up like that. All right. Find j of 3. So the integral from 0 to 3 of f of t plus 2 dt. And so I just want the area under the curve from f of 0 to 3, which is 1. Okay, so how do I know that this one's 6? So if I think about, it's 2, right? So it's this line. It's a horizontal line. It's pink. It's 2. What's the area under that? It's rectangle. So 1, because from here to here, this is 2. This is -1 down here, which makes it 1. So my answer is 7. And that's that. All right, super fun. All right, we'll see you guys soon. Have a great day.